Welcome back, students. Today we would be learning how to solve this cubic equation. So foremost, what I would be doing is I would be having x cubed on the left, and I would move out all of these terms to the right. So that would be giving me 6x squared, positive 12x, positive 8. Now I would be adding x cubed both sides. So when I do that, I would be getting 2x cubed equal to x cubed positive 6x squared positive 12x positive 8. Now this is actually x positive 2 raised to the power 3. On the left, we got 2x cubed. Now what I'm going to do is I'm going to be taking cube root both sides. Taking cube root both sides. Now clearly the cube root and the cube can be cancelled, giving me x positive 2 on the right side. And of course on the left side, I can rewrite this as 2 raised to the power 1 over 3 and x cubed raised to the power 1 over 3. This is going to be x, but this is going to be third root of 2 equal to x positive 2. Moving x to the left, I would have third root of 2 times x, negative x is equal to 2. I take x out and that would give me third root of 2, negative 1 is equal to 2. Now I can move this quantity to the right, and that would give me x to be equal to 2 over third root of 2 negative 1. This is the solution, but it's just not in the right form. So to get it in the right form, what we are expected to do is to rationalize it. So how do we rationalize? So we have got x being equal to 2 over third root of 2 negative 1. What I'm going to be doing, I'm going to be multiplying the denominator with third root of 4 positive third root of 2 positive 1. Of course, multiply the same quantity to the numerator. So that would give me third root of 4 positive third root of 2 positive 1. Now, if you were to multiply the denominator, we would get, I will be showing you here, just consider the denominator. Third root of 2 negative 1 being multiplied with third root of 4 positive third root of 2 positive 1. Now, multiplying we get third root of 2 is multiplied with third root of 4. Third root of 2 is multiplied with third root of 2, and then third root of 2 is multiplied with 1. Following it up for negative 1, we would now have negative third root of 4, negative third root of 2, and negative 1. Now, I can however rewrite this just for the sake of understanding. I'm rewriting third root of 2 as 2 raised to the power 1 over 3. Third root of 4, I'm writing it as 4 raised to the power of 1 over 3. This could be rewritten as 2 raised to the power 1 over 3 times 2 raised to the power 2 raised to the power 1 over 3. So this is going to be 2 raised to the power 1 over 3 times 2 raised to the power 2 over 3. So this is going to be 2 raised to the power 1 over 3 added with 2 over 3, which would give me 2. So similarly for the 2 raised to the power 1 over 3 and multiplied with 2 raised to the power 1 over 3. So this is going to be 2 raised to the power 1 over 3 added with 1 over 3, and that would be giving me 2 raised to the power 2 over 3. So this would give me 2, and this would give me 2 raised to the power 2 over 3. Now clearly, if you are to consider third root of 4, this is going to be 4 raised to the power of 1 over 3. Now this is nothing but 4 can be rewritten as 2 squared raised to the power 1 over 3, which is nothing but 2 raised to the power 2 over 3. So clearly I can cancel this with this. I can cancel this with this. And finally, I am left with 2 negative 1, which is equal to 1. So I have done all this just to show you that the denominator equals 1. Now for the numerator part, we've got 2 times third root of 4 positive third root of 2 positive 1. So the final solution for this question would be, therefore x being equal to 2 times third root of 4 positive third root of 2 positive 1. So this is going to be the final solution for this question. Now, however, the same question can be done in another manner. That would be by using Lagrange's resolvent. So what does it say? Now, if you are given a cubic equation, say of the form x to the power 3 positive ax squared positive bx positive c is equal to 0, then its resolvent equation is given by z squared positive 2 times a cubed negative 9ab positive 27c times z positive a squared negative 3b raised to the power 3 equal to 0. Okay, so this is actually a quadratic equation. And if you were to solve this, clearly the required x can be obtained. And that would be negative a. 2 roots would be coming for this quadratic equation. So z1 raised to the power of 1 over 3 positive z2 raised to the power of 1 over 3 divided by 3. So the question now is to substitute the values. The original problem so clearly from here we got a is equal to negative 6 and b is equal to negative 12 and c is equal to negative 8. So I'm going to be substituting the values here. So that would give me z squared positive 2 times my a is negative 6 raised to the power 3, negative 9 times negative 6 times my b is negative 12 positive 27 times negative 8 times z positive of my a is negative 6, that's squared, negative 3 times my b is negative 12, and that has to be raised to the power 3, and that is equal to 0. So simplifying this, so this is z squared positive of, this is 6 cubed, right? Multiplied by 2 would give you 6 times 2 is 12. 1, 2 ones are 2, 3, and 4. So this is going to be negative 4, 3, 2, followed by negative 9 of positive, 6 times 12 is 72, positive 27 times 8. So that's going to be 56, 5, 8 2s are 16, 17, 18, 19, 20, 21, 216 with a negative sign. That has to be multiplied with z positive. This is 36, negative, negative, positive 36. That has to be raised to the power of 3 equal to 0. Simplifying, we get z. So if we were to solve this using the quadratic formula, z is equal to 1296 plus or minus root of 1296 negative 4ac. So it's going to be b squared negative 4 times 373, 248 divided by 2. So let me use my calculator. So this is equal to 1296 plus or minus square root of 186624 divided by 2. And this one is going to be giving us plus or minus 432 divided by 2. So if we are going to be simplifying this, we would have two z's. So z1 will be equal to 1296 plus 432 divided by 2. So that's going to be 1728 divided by 2. So this will be 8, 6, and 4. So we have z1 to be as 864. This is one z1 value. And then the next z1 value, z2 is going to be 1296 minus 432 divided by 2. So that one would give you 864 divided by 2. So that's going to be 432. So z2 is 432. So we got z1 and z2. So we need to substitute the values over here. Okay, so we are expected to substitute the values for z1 and z2 and find the value for x. It's going to be negative of negative 6 plus 864 third root plus 432 third root divided by 3. So we will have to simplify this. So this is going to be 6 positive third root of 864 positive third root of 432 divided by 3. We have to use our calculator and find out what is the third root. The value would be 9.5244. And then calculate the cube root of 432. The value would be 7.5595 divided by 3. Now you can add these and that would be equal to 23.0839. That has to be divided by 3. So when I divide by 3, I would get approximately 7.6946. This is an approximation for x. Okay. Now the original solution that we got was this. Now I'm going to show to you that this is exactly the same value that we would get if we were to find the cube root and add up all this and then multiply it with 2. So let us find the cube root of 4. 1.5874, and that has to be added together with the cube root of 2, and that would be 1.25992 added with 1. So if I were to do that, then that would be equal to 2 times. Use a calculator and add up these values. So we would have 3.84732. You multiply it with 2, that would give me approximately 7.6946. The solution we have got, and both of them agree together.